Hello, everyone, and welcome to our monthly webinar. And as we start the webinar, just started raining incredibly.
A lot,
So, yeah. Okay, so let's wait just 1 or 2 minutes for allowing people to join. I see a few of you are already there, and the number kicks up. Today, I'm joined by Gabriele, which was planned, and unplanned guest,
Hello,
Steven.
everyone.
So with Steven, we'll, if we manage to get out of the office with this rain, but with Steven, we'll be doing some live demonstration that I think few company or maybe nobody has actually ever tried before.
I think live.
I've never seen it live, but we'll do it. Otherwise, it wouldn't be ZettaScale, right? If it's too easy, it's not fun. Okay, I'll start sharing my screen and we'll get going in a matter of few seconds. Okay, so my screen should be visible in a moment. And the slides will be available in the handouts section quite shortly, as well as the probably linked on again on the chat session. Okay, so let's wait 1 more minute. 3 minutes past the hour, we'll get started. So we were testing the demo this morning, was working smoothly, yes. But it wasn't raining. It wasn't raining. So hopefully that won't impact neither because
it's more fun if it rains.
Yeah, we never actually had rain when trying our demo. So we'll see what will happen. And we don't even have an umbrella.
I mean, maybe I have in my office, maybe.
Okay, well, I have it inside the car, but that doesn't help.
That doesn't help.
We have to get to the car.
Exactly.
Okay, let's go. Let's get it started. So once again, welcome to our monthly webinar. This month is the month of automotive, right?
Yep.
And we are kicking off with tackling V2X challenges with Zeno. So how is usually V2X implemented today? And we hear this all the time, right? And we hear, the technical implementation and the challenges that people have behind that we'll see in the next couple of slides. But many V2X solutions today are based on MQTT. And MQTT typically sitting on TCP/IP plus TLS because you need security. And usually it's even mutual
TLS.
Usually,
yes.
But as MQTT, as a broker architecture, that leads to this kind of systems in which you have an MQTT broker, and in fact, usually it's a cluster of brokers deployed on some cloud, and then your fleets of car or your car, whether you are OEM X or Y or Z, connecting to this MQTT broker. And that's the architecture that you get. So we've been interacting, let's say, supporting various experimentation of Zeno in V2X. And by now, we have listed at least the challenges that we're aware of that we're going to look into now. Well, the first and the most obvious is scalability. So I don't know if you guys know, but today, roughly 30% of new cars are connected. Okay. By 2030, 80% of new cars, right, will be connected.
Mm-hmm.
So the number of cars that actually will have to support connectivity will increase immensely if you consider that the market is growing at almost 7% CAGR.
Mm-hmm.
So how are you going to make that work? Right? So either you will have like a super muscular and won't work. Everyone understands that will not work. So that's the challenge number one. Let's look at the challenge number two. So localization and mobility are very hard to implement with crowd-centric technology. Why? So let's assume, instead of doing the webinar, we are going in Geneva for some reason, or maybe to Cannes. We would start driving from Paris and eventually maybe go to Cannes and then eventually to Geneva, because that's the way we decided to go through. And our session, right, and all the interaction will always be with the same cloud service.
Yeah.
And so if I want to provide any specific customization that depends on your current location, I need to make it explicit, right? It's not just a consequence of your location. And that gets quite problematic because it leaks location into the computation, and it would be much nicer, as we will see, if by some other mechanism, depending on where you are, I end up tapping into the right place, right? This is another big challenge. So imagine that the operator that this car are using has an issue. So the network is out and is out for sufficient amount of time to cause a disconnection. And then everyone tries to reconnect, which forces TCP reconnection,
And TLS and
mutual TLS and shake, and then the MQTT session opening, because there is no, And I mean, this creates serious problems because it's like a perfect zero-day attack, okay? So how do you deal with this? Well, we'll see it in a few slides. A similar problem actually occurs when one of the replica fails, because all of a sudden one of the replica fails, and because of this hub and spoke architecture, all of a sudden you have tons of machines that try to reconnect to some other replica and might cause, due to overload, also failure. And so that, that can lead to pretty unpleasant situation. Not to talk of edge computing, because many people, I think it's now understood wisdom, that in order to scale, right, you need to have some form of decentralization. But with an hub and spoke architecture, how are you going to decentralize? Where do you deploy the broker? I don't know. Do you know? Can you answer?
No.
Nobody knows. So, and even if you were to deploy MQTT routers on edge server, how are you going to route information within them? MQTT doesn't support these kind of features. So there is a huge question mark on how to address these kind of upcoming scenarios that are essential to deal with the evolution of connected vehicles with existing technology, and not to focus just on MQTT, but this is what is used today. Other technology have other limitation, and we've discussed this in the past, but this is the problem that we need to solve. Something else that actually we've seen recently poses lots of problems when you try to use MQTT in a cloud-centric architecture is video streaming. And that's not, I mean, there are really two aspects, but the one which I would like to focus on this slide is, again, the combination of TCP/IP, not necessarily TLS, but TCP/IP, and the way in which flow control is done over the internet doesn't make it very, very easy to stream video smoothly. Then there are some other aspects based on some evaluation that have been done of the throughput that actually MQTT can sustain. And I think for high resolution video, that also is a problem, especially in the backbone. Okay, so what is the solution? Well, if we are talking about it, it's kind of suspicious, right? So it sounds like we have a solution, and the solution is Zeno. Too easy. Let's try to understand why. So again, many of us have been in protocol since we were young kids, okay? I believe my parents tell me that I said protocol before saying mom and dad. What a horrible kid, isn't it?
It's concerning.
It's really concerning, indeed, anyway. So, but jokes apart, so when we did Zeno, in around 2014, we started working on Zeno, actually, at least, the desire to fix the problem that we were seeing. So when we started to work on this new protocol that eventually became Zeno, we really wanted to have a protocol that, well, first of all, could run on very constrained hardware and networks and run well on those environments, but also scale to very large scale distributed system. And we had noticed that protocols like DDS that we are very familiar, I mean, we've done massive contribution to DDS, right? Were favoring or were too much biased toward peer-to-peer communication in a full click. Other protocol, were imposing overview other topological constraint. And in fact, what you care is the abstraction, and what you don't want is the topological constraint. So one of the goals that we had was we do not want to have any topological constraint. And you will probably recall in the early days, people were asking us, why do you guys bother doing something so hard like mesh routing? Who needs it? I says, I mean, actually, you need it. Okay.
And then a few years later, they say, but you have mesh routing. That's very nice.
Exactly,
yes, we know.
Isn't it? Yeah, that's what we were saying. Yeah, but that's great. And so these are, some of the things that we could see, but not just because, we were Nostradamus or foreteller, but because we had been working, or we had a chance to be working in some system that were struggling with this kind of requirements before those requirements started becoming essentially mainstream. And so as a result, we designed this protocol that, again, doesn't have any topological constraint, doesn't have any, I would say, deployment constraint, because you can run on very small and perform on very large, and provides you with essentially universal abstraction for distributed computing by means of publish, subscribe, and queries. Okay, queries and queryable, as we mentioned. I'll articulate a little bit further. Something else that I think is quite important for the kind of system that people are trying to build today that are extremely heterogeneous, just because of their span, right, is the ability of running as low as a data link and being completely independent of the transport. So we don't need TCP/IP. If it's there and you want to use it, fine. But as a transport, we can run on serial, we can run on Bluetooth, we can run on OpenThreadX, Unix socket, shared memory, quick, serial link, and so on and so forth. Anything as low as data link, because Zeno does its own routing.
Indeed.
Okay, so Zeno actually is, in a way, a routing protocol, an information-centric routing protocol.
Yes.
Yeah. The core of our infrastructure is built in Rust. Why Rust? Because of security, because of performance, and because of productivity. And then we have language binding in several programming languages. And as I've already repeated a few times, it can run on very constrained devices like ESP32, Arduino, you name it, and has a few bytes of wire overhead when configured for minimal wire overhead. So this is kind of already covered. Let's zoom in on the topology. So with Zeno, you can do peer-to-peer, both on click as well as mesh. But you can have also client that peer up arbitrarily with peer and are then routed by peers. That's very useful for some robotics application. Then you have routers that can be used to broker information from the client, or broker information across networks on behalf of client, or route information in a wide area network among arbitrary Zeno applications. Okay, when you look at this diagram, sometimes people ask, what is the difference between a peer and a router? Well, a peer contains end-user business logic, and a router doesn't. And that's, again, kind of false, okay, or kind of true, depending on how you look at it. And I'll articulate in a moment. So I think the real difference is that a router is an infrastructural node. It's part of your infrastructure, and it doesn't represent your application, can be shared by multiple applications. Then the reason why we were laughing about the difference between router and peer is that you can still have custom code in a router by means of plugins, and we'll get there in a moment. So just to put into perspective how the topology of Zeno, or supported topologies by Zeno, differ and compare and contrast compared to MQTT and DDS, you see that DDS allows you to do peer-to-peer over a click. MQTT only supports the client-to-broker topology. With Zeno, you have no constraint. You can use the topology that makes sense in your system. So plugins. Well, you are an expert of plugins.
So that's where the user code is.
Yeah, so tell us a little bit about it, Gabriele.
So I say in Zeno router especially, what we could load plugins. What's the meaning of a plugin? A plugin is in general something that can augment the capability of the Zeno routers. So as we can see on the slide, we actually have like 3 main classes of plugins. Storage plugin that are a way to plug existing storage or existing database inside the Zeno routers. So as we can see from the slide, we have InfluxDB in the case we want time series, so both Influx v1 and Influx v2, or we can have RocksDB, which is kind of in-memory file system, SQLite in-memory file system. There's a way to persistent data that is being pub/sub. So let's imagine you want to publish some data and maybe get out the last data that was published for a certain key expression or topic name. You can just get that from a storage using the Zeno queryables. Of course, then we have other plugins like for Amazon S3, in the case you will want to store your data on the cloud, or Mini.io, which is actually the same API of Amazon S3, but you can run on premises. And if you need more performance, you can also store them in your main memory, or you may want to store some files inside your file system. You can also do that.
And it's completely transparent.
Yes,
you don't need to know where your data is stored. Neither you need to know where the data was stored, neither geographically, nor which backend when querying, which is quite nice.
So ideally, you can have, let's say, you can store the same information on multiple backends. And actually, what we provide is we provide also an alignment algorithm so that you can have your storage replicate across your network In case of network failure, we are then able to reconstruct the actual state of your storage.
And align it, yeah, absolutely.
Then we have protocol plugins.
Exactly.
So we've seen there are a lot of people, bunch of people using MQTT, bunch of people using DDS, bunch of people using REST, ROS,
HTTP,
HTTP, whatever, you name it. It would be nice if there is a way to get this data out of those protocols and put it inside Zeno. That's exactly what the protocol plugins does.
Yeah.
So actually what we have, you have one for ROS2, for ROS, for DDS, and for MQTT, plus, let's say, the REST plugin, which is kind of a special kind of plugin for the way we use it. But with DDS plugin, you are able to actually get information out of your DDS communication graph, so in this case from a click, and send it to Zeno, which is actually a way to scale your DDS deployment across a wide area network. So if you want to use Zeno, if you use DDS on your, let's say, your factory or your robot, and you want to have your robot
in your car,
and you want to be able to communicate across the internet, you should just start a Zeno router with a plugin there, or just a Zeno bridge for DDS, and automatically the data will go out.
And this has been massive. And by the way, I have a demonstration of this later on the slides with a car that goes very fast. and faster than mine.
Well, hopefully,
we won't go that. We won't go that fast. Don't worry. Don't
you
worry.
Can try.
He's always afraid of Italian drivers, right?
But we messed the runtime plugins.
Sorry?
The runtime plugins also we have. So
of course.
What we have is a way, let's imagine you want to have some in-network computation for your data. So let's imagine your car is using DDS, so maybe it's using ROS, and it's sending out some data with a certain type that maybe is encoded like in CDR, or that is the ROS type. Maybe you would like to see this data on a web interface, but you don't want to actually implement the transcoding on the web interface.
Yeah.
So what you could do, thanks to Zenoflow, is having some data processing inside your Zeno network, which means that the data is going to be processed directly inside the network, and means that in this case you can do transcoding, you can do, I don't know, average calculation, whatever you want. I mean, you really need to pick.
We covered Zenoflow in our last webinar, so
exactly.
Please refer to that if you want to learn more about it. Okay, let's keep going. And as we were mentioning about performance, so when I was hinting about video, I want to go real quick on this slide, just to show that in terms of throughput on a 100 gigabit network, Zeno gets actually better than anything else that was measured in this evaluation done by NTU, which were DDS, MQTT, and Kafka. So you have light blue and violet that are Zeno peer-to-peer and Zeno brokered, and the scale on the y-axis is logarithmic. But you see that depending on the payload size, there is this strange behavior that MQTT exposes in which the throughput drops. And that's very problematic for video where you have large payloads because you have images, okay? So really the problem that MQTT has when dealing with video is on one side, TCP/IP. On the other, it's MQTT itself with this problem of, I think it's
more than what?
Than actually 32 kilobytes.
So it's not even that much.
Yeah. Okay. Now, all of this might sound very complicated. You say, oh my God, how am I going to deploy all these routers? Well, that's why we have the Zetta platform. Right?
We do it for you.
So come on, tell us a little bit about the Zetta platform. As you are the architect of the Zetta platform, you should know better than me.
Yeah, I hope so. Otherwise, we have a problem.
Yes.
So actually, we have seen Zeno. Zeno is very easy to use, especially from the API side. We had a lot of users say, the API side is very nice. We are able to do our very complex application. Everything works quite nicely, but actually, we do not want to manage Zeno routers. We don't want to bother with creating machines on the cloud or machines on the edge and so on and so on. So what we did, we started working on the Zetta platform. The Zetta platform is kind of a magic wand to manage all your Zeta software, which includes Zeno, includes DDS, includes bridge between the different protocols. So the idea there is that for users to just have a very simple web interface from which they can decide where to deploy those Zeno routers, how to configure them, and actually also download and generate all the configuration for their client application. All of this with security in mind, and also with the possibility to deploy a router on premises, which means I could decide for my deployment, I want one router in the US, one router in the EU, because maybe I have one factory in the US and one factory in the EU. And then I could say, but you know what? For each factory, I would like to have a local router because I don't want to stream all the data.
A series of local
routers, because I don't want to stream all the data out to the cloud, actually, because it's costly, it requires a lot of bandwidth, and maybe also for security concern, I want just to keep some data local to the factory.
About energy consumption?
Also energy consumption, because at the end, we also talk a lot about having an energy efficient device, but most of the energy spent in communicating.
And then we waste essentially the way in which you communicate.
Exactly. So if, for instance, we communicate with the machine that is just aside of the other one, it has to go to the cloud and then back, it's kind of a waste of resources.
A huge waste. Yeah.
So in that case, what you could do from the platform, you can just configure a router to run it locally. And this router will be security automatically connected to your cloud routers. So that in the case you need to get some data from, I don't know, from some factory management that maybe is a dashboard that you want to see, that you will get data from the cloud, but only if it's needed, not all the time.
Let me show. This is how typically it looks.
This is how typically the platform, looks like.
Yeah. And by the way, it is cloud independent.
It is cloud independent.
That's an important point,
because we base the technology per se is cloud independent. The way it's based. So far, we have deployed. So we provide in Zetta Platform only AWS, but we have the plan to provide also other cloud providers, and also to facilitate the on-prem deployment by supporting natively Kubernetes.
Yeah.
So that is, if in your factory you have a Kubernetes deployment running, or inside your office, or inside your IT infrastructure, or inside your own cloud, maybe you can just provide us with you can just download a binary, put it inside your Kubernetes cluster, and from there automatically deploy from the same web interface.
Yeah. So we support same connector as Zeno, so the principle is the same.
We just
with the advantage
that all the configuration is very simplified.
Yeah.
Instead of in there, look, I need to write this configuration file in this certain way to say, you know what, I need a Zeno router with a DDS bridge. I need to route these two topics. Okay, fine, generate, and you just download the configuration.
And as in this example, you
provision, can see, yes, exactly. From this case, in this example, we had our Zeno router running on your laptop, and we can see a bunch of routers on the cloud, and also some application connected to the infrastructure.
And so we have done a few webinars, so there are quite a few interesting videos that goes in depth on the Zetta platform. Don't hesitate. And if you want to play around with it or want an evaluation, just reach out. Okay, real quick on adoption. And by the way, so you have a strong robotics background, don't you?
Absolutely.
So before we get to robotics, how was, and you're relatively, let's say, I would say relatively new. You're not so new to the team anymore. Yeah, but
it's been a year already.
Yeah, so it's still kind of new. So how has been your experience with Zeno, coming from a robotics background so far, Stephen?
Oh, it has been absolutely amazing. I think, and it was one of the things that I first noticed about Zeno, that it solves a lot of the robotics challenges that we have out there in the industry. Of course, related to communication, but I think all the other or the new features that are kind of introduced to the space, and I think they're going to become very valuable in the future, especially now. Well, I guess we're going to talk later on about it, but especially now that we will have a Zeno RMW implementation in the future.
So yes, on this we'll dedicate an entire month to robotics, which is next month. So we will have deep dive on Zeno in robotics next month. So talking about robotics, Zeno really helped communication between robots, because the large majority of robots today are mobile, right? And some of the technology that are used in those platforms, like ROS, were designed to work well in fixed network. And I think this is what has caused very massive adoption of Zeno. Eventually, as you mentioned, the Zeno RMW alternate, which was quite huge. So people that didn't read the report, I strongly suggest you take a look. And Zeno becoming very quickly, the preferred middleware in the ROS community, which was incredible for robotics. And if you think that it is estimated by analysts that 80% of mobile robots run on ROS2, this is huge. It's incredible. Okay, if we look at automotive, Zeno has also experienced strong traction in automotive, both for in-vehicle as well as V2X. I'm still kind of trying to resolve, right, how this has happened. I mean, we know that it makes sense, right? But and I think there are mostly two reasons. I don't know what you guys think. So that will be interesting short debate. So on one end is kind of the convergence between robotics and vehicle, because vehicle become more and more like big robots. And the second one is the struggle that there is also in automotive, because a car today is a microcontroller to cloud, or cloud to microcontroller system. So having a technology can run end to end, it's very appealing. Do you have any other takes?
No, I think, as you said, a lot of people that started working in robotics, especially with ROS, then they moved to automotive. So that explains that their experience with Zeno maybe has helped a lot on getting also traction in automotive. And as I said, most of we had actually users that say, we have our cars communicate MQTT with the cloud, we have problems. Can Zeno help in solving those problems? And actually we are trying to
and then they see what has happened in robotics, and many people use ROS actually in R&D, even if it's not using deployment for, or the series development.
I've seen, let's say, autonomous car running ROS actually in this area.
Yeah.
So
Indeed.
So for R&D, it's really
Indeed.
used. Then maybe in the actual development, no.
And then a couple of years ago, we got this recommendation from ITUT. I'll go quickly because we need to. Eclipse SDV started adopting Zeno, gave additional visibility, and then the apex last year when GM selected Zeno as your protocol transport, and we're working together as part of the Eclipse SDV very, very well. Okay, and this is the fast car I was promising, right? So this is again a perfect example of a car that is a robot, in fact, because it's running ROS 2.
It's running ROS 2. It was
and
running
all
a
the
bridge,
and all. So tell me how it runs. Come
so
on.
actually inside the car, so it's a Dallara car in which this was the India Autonomous Challenge. Inside this car, actually there was some ROS nodes. So actually we're running ROS application. But the problem there was that this car has to communicate with a brain, that the brain was not running on the car. The brain was running at the edge infrastructure. And the network being used there was a Cisco proprietary network, which
was
Cisco
Universal Wireless. I mean, it was working well, but had plenty of constraints.
It was not working well, I would say, with multicast. UDP multicast, which was the thing used by default in ROS 2 for communication. So what we did there, we said, look, we have a way to solve it. Just start a Zeno router there, start a Zeno bridge there, connect to a Zeno router on the other side or a Zeno application. And I think we started with it. That's actually showing it that it
and again, so there was the multicast issues, that there was the bandwidth issues, and the packet per second issues. So there were quite a few challenges.
So actually, what you can do with the bridge, you can also limit the number of messages sent per topic. So you can downsample in the case you need it. And so you can do quite nice things that actually help this.
But that's very high performance V2X, let's say. Okay, and that leads us very well into how we can address the V2X challenges with Zeno. So the first challenge we look at was with the scalability. Well, based on what we saw so far, it should be clear that with Zeno, going forward, you will be able to build this kind of architecture. And if you think how 5G looks, how 6G will look like, I mean, 5G, I think some of us were disappointed because we were waiting for edge infrastructure to be able to use, and it's not there yet. As we learned last Friday, there are some companies that have not given up, right? But with 6G, I mean, this kind of architecture will be coming because, you will have the server on the edge, but then you will have the microcell, the nanocell, the picocell, and those are all places where you can have computing, where we could deploy Zeno router, and all of a sudden would become a very vascular network. That's how you scale, right? And this is how we would build this kind of system, improving latency because all of a sudden communication is local, improving resilience, actually resolving the problem, as we'll see in a moment, of the 0 day. Okay. Because the chance that all of them die,
at the same time, it's very low.
And even if they will, the work is so distributed, right? That
so you not get one single router getting 1 million connection.
Exactly. And so, if we look at the mobility challenge, as we saw in a centralized architecture, it's very hard to just have natural localization. Once again, with a decentralized, with an edge infrastructure and with Zeno, as you move, you would have session migration, and naturally, you will be interacting with infrastructure that is local to you, which means any query would be resolved by the local infrastructure, which means exactly the same query. If I'm in Paris, I'm in Cannes, and I'm in Geneva, will give me different data without nothing special, just as a consequence.
Leveraging context information, which is the most important thing.
Exactly.
And
so go ahead.
So let's imagine one of the car maybe is asking the state of the road. If this state of the road has to come through the cloud, all of a sudden you have to stream your position to the cloud, and maybe has to go back and fetch the data. There you can have the server where Zeno router is running that is posting a query, which is state of the road. And if you're in Paris, the state is one. If you're in Cannes, the state is another one.
And then how about load balancing? Because if all the requests go, it becomes a complete mess.
And also you had a lot of latency. Every time you have to go to the cloud and back.
And here it's so natural. And we've already experimented with this sort of things since a couple of years. Okay, network recovery. You kind of already guessed the answer because this is the problem where you have very centralized architecture. But again, if we decentralized, even if we were to assume that the operator dies completely and then restart, the load is so much more shared that doesn't create as much problem. And So suppose that then, for some reason you say, but I love hub and spoke. I want to do an hub and spoke with Zeno. Well, you can, right? I mean,
Of course,
if
you
you
do
want,
whatever you
just,
want.
yeah, do whatever you want, as far as you're happy with it,
Yes.
right? If you're happy, we are happy. So, but in this case, even in that architecture, what would happen? Well, you would run ideally Zeno over quick.
Yeah.
Which in this case would have that zero time session opening.
Establishment, yes, because that is a feature that is in Quick, is a feature that will be also in Zeno soon. So the idea there is that, with Quick, the way it works is that once you connect the first time, then you can reconnect in a zero RTT, which means you don't need to do a usual 3-way or 4-way handshake of TLS, which means that you can open the connection way quicker.
Well, and by the way, in the case of TCP/IP and TLS,
yes,
right, you have to do
double the handshake.
Exactly.
Because you have the 3-way handshake of TCP plus
exactly.
4-way handshake for TLS. With Quick, you do usually 3-way handshake to open the TLS, to open the session the first time, and then it's
just one.
It's one way, so it's just one.
And again, with Zeno, there are some optimization, but even today, with a sufficient long lease, your session ID would be still valid.
Yes.
So that's, even in this case, we can do it better. And again, if tomorrow there is zip as opposed to quick, well, we'll do a plugin.
Just a matter, it's what, 3 days of work implementing a transport. So
it is.
The day there is a new transport that maybe solve all the issue in the world, maybe we can use it.
Absolutely.
It's completely fine.
And I still, one of my dream is still to have native integration with a 5G network provider, because
that means the network provider.
Yeah, that would be just unbelievable. Okay, now edge computing. Again, so much challenging with, because of the topological restriction of MQTT, but well, with Zeno, as we saw, it's natural. It was built for, right? And again, we sometimes tend to say as a company that, we don't like necessarily the term edge computing, because the truth is that edge is very subjective. You cannot draw an edge, right?
Depends on your use case.
It depends on use case.
Yes, is the radio access network. For a factory, could be the on-premises infrastructure. So each one comes with its own edge.
Exactly. Or could be, in some case, could be my car, because I have a server in my car, right? So the reality is that there is a continuum.
Yeah,
there is a continuum where we can compute, store, and communicate, and that's where we need to live. Exactly. And that's where Zeno flies, right?
Exactly. Yeah.
Because it was designed for this. And by the way, even if you wanted to leverage edge computing today,
you could with Zeno.
How? Let's ask him. Let's see if he was paying attention.
Well, with the plugins, right?
Of course.
Got it.
Just with the plugin? So?
Well, with the type of plugin that
so
you want to
MQTT.
implement. In this case,
actually,
for example, the MQTT, right?
For instance, let's imagine your device in your car talks MQTT. And usually they're configured to talk with the cloud. But what you could do, you can just start a Zeno bridge MQTT in your car and configure everything that is in your car to talk with this bridge. So you don't need to touch your code, actually. The code in your car is always the same. Just need to change where it connects to and then use Zeno to achieve.
And you can even mix and match, as you see in the picture, because you can have new car talking with Zeno natively.
Yes.
Use Zeno to route between MQTT brokers. So
kind of drop-in replacement.
Exactly. Which is what we like, right? And video. But we've been talking too much, haven't we, Stephen? And we have been talking, and now we're going to do some real work.
Let's go for the the Zeno card.
Yeah.
The fun part of the webinar now officially starts.
Yes.
So what is going to happen now is that myself and Stephen, and thanks God it's not raining anymore, are going to step down, get in my car, join the stream on YouTube, because in fact I will be sharing this screen for a moment, just for a moment. And actually, no. I will not stop sharing, because as I get down the car, you will explain what is going on, and then you will start the stream. You'll stop the sharing and start the stream.
Stop the sharing and start the stream on the other side.
Okay. So this is the window, and I think, okay, great. So Gabriele,
see you in a few minutes.
See you ping us. And by the way, I need to unplug this because I needed to plug my mobile.
Okay.
But you should have plenty battery.
Yeah. It's full. 100%.
Okay, guys, we'll see you on YouTube or LinkedIn. But the link that probably Daniela has posted in the chat. Okay, let's go.
It is under the car.
So I think we have all we need because the car is in the car. So let me just get
Can you
my
lend me
driving
the,
license.
well, I don't need it. The charger, the cable for the charger. Okay.
Okay.
So see you in a few minutes.
Yeah, see you.
And meanwhile, I will explain what we are
Sounds
going
good.
to do. Okay. So while Angelo and Steven go to the car, to the Zeno car actually, to prepare everything for the demo, let's see what is the demo about. So we create an infrastructure, in this case, on the Zetta platform, in which we put different Zeno routers in different regions. In this case, we have something running in Japan, something running in US East Coast, and something running here in Europe, very close to us, well, actually in Frankfurt, so a few hundred kilometers away. And then to this infrastructure, we are going to connect some applications. We will have, of course, the car. And in the car, we will have a camera connected to a laptop, connected to a 5G phone that is going to stream some video, so some real-time video, as the purplish kind, the pinkish kind of arrow is showing. And this car will be connected to the Frankfurt router. Why with the Frankfurt? Well, because it's the closest one in this case, and as we are using commercial 5G, so a consumer 5G deployment, we cannot have access to actual edge infrastructure. Then what we are doing, we will start some AI, some classification algorithm running in our office, so completely on premises, connected to a Zeno router that is also local. So what we have here in our office, we have a small, let's say, data center in which we started a Zeno router, connected, of course, to the platform. And inside this data center, we also started an AI algorithm that is able to do classification on images. In particular, is a YOLO V7, I guess, algorithm. So it's going to be able to detect cars, pedestrians, and this sort of stuff. And then we are going to connect to this actual laptop, the laptop I'm used for the presentation, another application that is going to get the data out of this algorithm, so the classification. And we are also going to stream the classification back to the car. Though the idea there is that with Zeno, we are able to actually stream this data real time or almost real time with very low latency and using actually devices that are already there. So we just started something on our premises to have the Zeno router. We started a Zeno application on my laptop that is open source, so everyone can just get it and run this Zeno application in the future and getting data directly out from the car. And the idea there is that first, Zeno is capable to provide real-time capability, so provide real-time data streaming for videos, and also that is a way to show how in the future cars could leverage communication with that infrastructure. Because let's imagine you have maybe in a city different cars that are going through an intersection. Maybe they don't need to run actually the object detection algorithm in each different car. Maybe you can have some cameras in the intersection that are able to discover all the car and send just to the other cars, okay, look, on your left, there is this car that is going to go right, so maybe you need to stop, and so on and so on. Or you can leverage in general the edge infrastructure in a way that to offload some of the computation, which in some case makes sense, some case makes less sense. Depends really on the use case. These allows, of course, if you all of a sudden you don't need to put powerful GPUs or GPUs in general inside the car to perform some AI detection algorithm, maybe the car will cost less because all of a sudden the hardware is not there. So of course you can reduce your cost and you can leverage on the infrastructure when it's needed. Imagine the same thing could happen for parking slot. For parking, in parking, I actually maybe don't need to have the algorithm running itself on the car because maybe I want to update the algorithms and so on and so on. It can run on the edge and leverage on the edge infrastructure, communicating with the car through Zeno to actually drive the car and gets the result. So that's actually what is going to happen. So let's wait for Steven and Angelo to be there. Actually, let me start the streaming on the other side. So stop the screen there, and let me start on the other side. So what I need to do there. So we see Steven there. Hello, Steven.
Hello, everyone. Can you hear me?
Yes.
Great. So I'm here with Angelo. As Gabriele just explained, this part of the webinar will be somewhat more dynamic, so to say. So let me quickly go through the setup. Maybe while I do so, Gabriele, you can continue explaining if you're missing something.
Yeah. And by the way, just as now they can see the clear sky, show the rain outside because the weather is completely crazy.
Yeah, I will do in just a second. So let me just change the camera over here. Well, now maybe this is better now. Can you guys see my background?
We see your laptop.
Great. So what we have in here, I don't know, Gabriel, if you already explained this part, but
Yeah, I did. You did, but we can show the different parts. So
great. Go ahead.
We have the phone. That's Angelo phone connected to 5G.
the camera,
Yes.
Oh,
the laptop, and that's it. And the car.
In the car. Yes.
Let me just
Okay, so I think you can start sharing your screen then whenever you want, Gabriele, to show the feed.
Yes.
Let us know when we can get started. So let me put my.
Now you guys should be able to see my screen. And actually, we are already seeing data coming from the car. So you see that in
great.
front of the
So-
car, there is another car.
Shall we move?
Yeah.
Let's go.
for it.
Do you see us moving?
Yes.
Great.
See how many cars there are there in the parking slot. So we can see it rained before. So now there's a bit of sun. As we can see, what is actually happening, as I described before, this data is coming out from Steven laptop, actually. So from the camera connected to Steven laptop, going through Angelo phone to send this data to the cloud in this case, coming back to our office, actually, being processed by the AI. And then the AI is going to add, as you say, is going to add a bit of information like the time that is used for inference, how many objects are detected, and of course the bounding boxes. So as they will approach the traffic light, we are going to see the bounding boxes for the traffic light, of course, some car detector there on the left and other signs. And of course, as again, the focus there is not the algorithm per se, is seeing that we can actually stream this data live directly from the car at real time. So you see the traffic light is red, so Angelo stopped.
hopefully.
I did. Don't worry. Yeah.
And we can see that there are a bunch of traffic light detected. Of course, then the algorithm is saying that those small signs are kind
It's
of
green.
Yeah, it's green, so we can go. Again, all of this is real time. I mean, the guys are in the car, as you can see from the stream, and they're actually, Angelo is actually driving while doing this, and we are connected to a consumer 5G network. So without any dedicated slice, anything. And this is just pure Zeno latency at the end. And of course, the phone is connected, of course, through TLS, via Quick, as we said before, to the cloud infrastructure. And actually the same is happening in this
And
case.
by the way, Gabriele, without an edge infrastructure, right?
Without an edge infrastructure, yes.
Yeah. Because that's also quite important to gather. Yeah.
So indeed, so still there will be a bit of latency. I think in this case it will be few hundred of milliseconds, but that could be easily improved if we had Zeno running inside an edge infrastructure, if we had a dedicated slice for our car data. So we need to keep in mind always that, I said, this is a commercial deployment, a consumer deployment for the 5G. So no edge infrastructure, but still Zeno is able to get this kind of performance. And we forget about the AI thinking that the fields is a train.
Yeah, well, that's systematic for some reason, right?
So do you want to explain a bit where we are? So the area, maybe?
Yeah, so this is the Plateau de Saclay, which actually is the innovation cluster, the biggest innovation cluster in the entire Europe. And here on our left, there is the Commissariat pour l'Énergie Atomique, which is a research center that does research pretty much on anything, starting from foundational physics up to anything you might imagine, like compilers, software operating system, blockchain, and so on and so forth. They did, for instance, the experiment that discovered the boson, that demonstrated the existence of the Higgs boson, was done by a team here at CEUA. We just left an accelerator, and over there, where is our office, roughly, right? There are all the top engineering schools and many other innovation centers and companies like ZettaScale. And we're going to take the Highway 118 to then get back to the office. But we will do the Q&A from the car.
Yep.
So we'll, once we get out of the highway, maybe we'll do the Q&A, Gabriele.
Yeah, indeed. I mean, it's just to show that actually also going on an highway, so around 90 kilometers per hour. The
We can
communication
go up to 110 over there. So yeah.
As you wish.
preferably not, but
That's the speed limit.
It's the
That's
speed
for
limit,
demo
so it's
sake.
fine.
That's for demo sakes, guy. Not because I like speed.
I mean, unfortunately, there is not that much car now on the road, but
we have some traffic lights over here.
we have some traffic light. Traffic light is always there.
On the highway will be better. We have a car behind us. Maybe I will let them overtake. I will ask them to overtake.
We can actually see the car.
So we
Yes.
will see a few cars in front of us. Yeah, that's good.
So we have a few cars. So we have a Dacia, as we can see.
Yeah, you have essentially no latency. Yeah?
Yeah, no. That's exactly the performance of Zeno. Showing no
Exactly.
latency. I mean, nothing at the end is really optimized in this case because we are using everything from. We are going through the cloud. We could go through the edge if we had an edge infrastructure to further reduce latency. And actually, in the case, let's imagine you want to use something like this for digital witness use case. You do actually not need low latency. You just need to be able to get the data to store it, to be able to reconstruct the scene of an accident in the case you need.
Yeah, but this could also be used to do, let's say, eventually advanced ADS, right?
Yes, advanced autonomous driving. Yes, autonomous system.
And it could be interesting because all of a sudden, if your car, because those servers are very expensive. So if you imagine some cheaper car that you only use in citadine environment, I mean, you could have the brain sitting on the edge.
Exactly. That's exactly what I explained before.
Yeah, we have demonstrated that already with robotics, right? We did the Dragon bot, and now we did the Dragon car or whatever. Almost. Yeah, here there are more cars, so it will be more fun here.
Yeah. You see some people overtaking you. Yeah.
Yes. They don't realize that we are into a demo. No, but I'm because I'm going too slow. They're right. Not even 70, and the speed limit here is 110. So we are speeding in 110.
So we can see all the cars, are being detected. So it's that's perfect. Actually.
Gabriele, should I get out or drive?
Yeah. I mean, you can get out. So and then we can start getting Q&A.
Yeah. Okay. Let's do that.